Assalamu alaikum dear students. Bismillahirrahmanirrahim. Welcome back in lecture 32. Okay. In this lecture, this is the end of session 4. Okay. Of the session 4 is all about the analysis of indeterminate frames. So we did, I think so, 10 to 12 examples. Okay, of indeterminate frames. In this last lecture, basically, I will show you that how a multi-story and bay frame is modeled in SAP 2000, and their modeling, and I will attempt my last frame that is right on my screen. Okay, so inshallah you see that uh, the best and interesting part of this lecture is this first portion. Okay, and first portion of this lecture is basically I am modeling this frame. Okay, these these two frames are basically, you can say, it provides a foundation for your coming lectures, in which I am going to design basically frames. Okay, so it will be it will work like a foundation for you people. Okay, you must understand that how we basically model a frame structure, okay, through grid spacing. So uh, you need to become the master of of modeling of a multi-story frame. Clear? So let's start. We will first attempt this one and then this one. Clear? This one is simple. We have only one bay. Clear? We will assume the bay width, okay, any value we can assume, and we have two story, okay, three story, sorry, and you can assume any story height. Clear? So this is just only I want to show you that how we model, okay, a frame. Clear? So this is a kind of model, a two story frame. Okay, so you can compare this 2D model basically with a real world problem. Okay, like let's say this is a two rooms, or you can say two shops, which is constructed over each other, and you know this is one side view of that uh, structure. Clear? This is fixed support and this is hinge. There may be, you can say that this will be a steel column. Okay, and if you draw the 3D view of this, so you can see somewhat like this. Clear? There will also same frame. This frame is toward that side as well. Okay, so this will be that footing is also a fixed footing, and this one is a hinge. Clear? And this is its first floor. Okay, it is somewhat like this shape. Okay, so this is first floor and this is second floor, or you can say this is roof and this is ground floor. Okay, so you use this frame is basically the one view of this frame of this building. Basically, practically, when we are designing any structure, we just select its only one or two sides. Okay, so one or two sides, one or two 2D frames, and we uh, analyze that 2D frame, and we determine the maximum bending moment and maximum shear, and then we provide steel for that section. Okay, so this is a kind of 2D frame of a building. Okay, so the modeling of this 2D frame is simple. You just select the 2D frame template, and in that you just insert story, number of story 2, story height you can assume it, and number of bays only 1, and the bay width you can assume it, and just OK. So this will be drawn. Now this one is a little bit tricky. There are basically we have 1, 2 and 3. If you are using grid only, you have 2, 3 axes. In x direction you have 3 number of grids, and if you are in z direction, basically you have 1, 2, 3, 4 and 5. So you have 5 grids. Okay, let's say I will show you. I can use this one. Okay, I can use it. Okay, if it is symmetry, this frame is symmetry, all story heights are equal and bay widths are equal, then it is very easy for you to use this option. Okay, this is very easy. Okay, but if the bay widths are different, and story heights are different, then it will be a little bit difficult. This one and this one gives you then same result. Let us use this one. Clear? Here you have number of stories. How much? Now count it. 1, 2, 3 and 4. You have 4 stories. You can assume each story height, let's say they are constant, and let's say they are 4 meter. This one is also 4 meter. Okay, so all story heights are same. Clear? Story height, let's say 3 meter. We have 2 number of bays, and let's say the bay width is 6 meter. Okay, and just select OK. So this is what was the mistake? What was the mistake? This one, number of stories we have, basically how much? Number of stories we have 5 stories, 4 stories, 1, 2, 3, 4. We have 4 stories. Let's say story height is 3, number of bays 2 and bay widths, and let's say OK. So this is the way that how we will model a multi-story 2D frame. Clear? It will help you in coming lectures. Okay, you can change, click it, edit grid data, modify and show. Now here we can use spacing. So you can modify, you can add other grids as well. Okay, so from A to B you have 6, from B to C you can change it. Let's say this is 4 meter. Then you can add it, like let's say I will add it. I have D, I have grid E, I have grid F. Okay, and let's say from C to D I have 6 meter, from D to E I have 2 meter. Okay, from E to F I have 6 meter again, and then I have 0. Clear? You click on it. Okay, and similarly we don't need, because we are in 2D, we don't need this Y-grid. If we are in 3D, then we need it. Clear? There you see, you can change, let's say from Z2 to Z3 I have 4 meter height. Okay, and similarly I added other stories as well, like in this way. So select OK, select OK, and you see your grids now are changed. Okay, so now these members are are fixed here. Okay, you can, I think so there is an option which can change this. Okay, which can change this, and it moves. Okay, it can change. Okay, it can move. Okay, so in later stages, inshallah, you will see that how we will use these grid lines. You can delete this one, and you can delete this one, and you can add new one. Okay, how you can create new one? Select on that option, click on this one, click on this one, then click on this one, this one, this one, this one, and then this one. Clear? You can use your quick option as well, which is this one, and by just clicking you can see the columns and beams will be drawn. Okay, it will help you in inshallah in our I think so. You can select it. Selection will work, but so in this way you can create your beams and columns of different shape and okay, of different sizes, of different cross sections. Inshallah, in the last session which in which we are basically dealing with the design, so you will understand that how we will use these grid lines, these grid data for multi-story frame. Clear? So this was just only I want to provide you a kind of foundation. If you face any kind of multi-story frame, 2D frame, so how you will model it. You can assign their joints. Okay, just click it and assign joints. What joints you will want, you can assign. Clear? Let's say fixed, so all they will be fixed. So this is a kind of modeling of multi-story frame. Okay, now we come to solve this frame. Okay, this frame is basically a 2-bay frame, 1-bay and 2-bay and 1 story. Okay, so you can see the bay widths are changed, story height are constant. So let's see and we do this example. Units are in kf feet. Okay, kf feet. Clear? Select this one. We have 1 story bay width are changed. Okay, so we will change it. Number of bays 2 and story height is constant. Okay, that is 16 feet and number of bays 2 and we edit the bay widths. Clear? Now spacing, make sure feet you will be in feet. From A to B you can 12 and from B to C you have 16. Okay, 12 and from B to C you have 16. Okay, so this is the way that how we will develop. Okay, now we don't need this one. Okay, so delete it and A, E and D. Determine the moments at B and C, then draw the moment diagram for each member of the frame. Assume the supports at A, E and D are fixed. This one, this one, this one are fixed. Clear? So delete it. Okay, select this joint, select this joint, select this joint and assign it as a fixed support. Okay, as a fixed support. Rotate this one, assign joint local axis with about y axis. Clear? Okay, now assign loading, frame loading, that is distributed. Check, you have 2 kf and the other one is 10 kf. So make sure this is 0. Okay, modified. Okay, add this one or this one, both will work. global gravity and 2 kip per feet. Okay, assign frame load, point load. You can use this one or this one, because I don't assign any load to this member. Okay, so therefore this is, and first if you are assigning a load to an element, you can use both option. But at the second attempt, if you are using another load to this member which you have already assigned another load, then you will use this one. Clear? Gravity and the amount of the load is at a distance of 8 feet, we have a loading of 10 kf. Clear? And okay. So this is the way. If you are interested to show the loads, select this one and okay. This is the loading. Press the run analysis option. Model do not run. Run now and save it. This is example number 42. Sorry, 43. Okay. These are the results. Okay, and this will be the bending moment and shear force diagram. The maximum shear is at a distance at a fixed support. Okay, that is 25.42. You can show the shear force diagram as well. That will be the shear, and the maximum shear will be at fixed support. Clear? So this is the end of this session 4. If you have any question, any suggestion, any comments, you can share with me on my accounts. Okay. In the next session, inshallah, I will trying to cover some example on trusses. Okay, determinate and indeterminate. And in the last session, basically, we will do design examples. Okay, we will design beams, inshallah. We will design frame structure as well. So different types of examples, inshallah, I will suggest some practical examples. Okay, some projects, inshallah, I will select it and I will show you that how those structures are analyzed, how they are designed. Okay, and then inshallah that will be the end of this SAP courses. So watch the video, enjoy, and thank you.